Kia ora te whānau. Here's question 4 from March 2016's Pure paper. This is one that looks at the factor theorem, and it's quite a cool question because it's just a little bit different from the ones we see all the time. So I've just put it on here so that you can see it. I'll put it a bit bigger on the next slide. So here we go. We've got a polynomial, and it's got an a sitting in here. So a is a constant, and we're told that 2x plus 1 is a factor. So as soon as we see that, we should be thinking about the factor theorem. We have to start out by figuring out the value of a. So we're going to start by writing down, by the factor theorem, we know that p of negative 1/2 is equal to 0 because 2x plus 1 equals 0 has a solution of x equals negative 1/2. So what we need to do is to substitute in negative 1/2 and solve what we've got. So we have 4 times negative 1/2 cubed plus a times negative 1/2 plus 2 is equal to 0. So what does that give us? Well, we get negative 4/8 minus 1/2 a plus 2 is 0. Collecting all of that up, we get negative 1/2 a is equal to 1/2 minus 2, so negative 3/2, giving me a is equal to 3, which is nice. It's a nice round number. Let's go and chuck that back into here, and now we're going to factorize p of x, and then we're going to solve this inequality. So it's 4x cubed plus 3x plus 2. So 4x cubed plus 3x plus 2 can be factorized as follows. Well, we know, whoops, we've got this weird shape thing on. Let me turn that off. It is quite cool how it does that though. Right, but here we are. Here's 2x plus 1. Right, now we've got to factorize the rest. Now, I'm just going to do this by inspection. I did this in a video a couple of days ago. Make sure you can do it. So we've got 2x times what will give me 4x cubed. Well, I've got 2x squared here. Right, looking at the next term, that gives me a plus 2x squared that I don't want. I have to undo that by subtracting out a minus x here. Right, now let's see what that gives me next. It gives me minus x, and I want plus 3x. So here we're going to have a plus 2. Now doing it that way makes it really easy also to check that my constant matches up, and it does. So we're all good with that. That's factorized so far, but let's see if we can fully factorize it. So if we just look at that for a minute and try to do guess and check on it, because it's a pretty easy looking quadratic, you'll see that you can't. And that's going to be the key to the next question, right? We have to solve this inequality, justifying our answer. So factorizing p of x, let's just see if we can go any further with this. The only thing I'm hesitating about here is that we could factorize it if we went to complex coefficients, right? But we're not going to do that. Let's see. So I can tell that this bit has got no further to go by looking at the discriminant. So let's look at b squared minus 4ac and see what we've got here. So we've got negative 1 squared minus 4 times 2 times 2, which gives me 1 minus 16, negative 15, which is less than 0. So it's got no real roots. What that means is that 2x squared minus x plus 2 is going to be strictly positive for any value of x. And that's because this is a parabola, a right way up parabola, so it's going to hang somewhere up here like this. That helps us solve the last bit where we're asked to solve the equation, solve the inequality p of x is greater than 0, justifying our answer. So what have we got? Well, we've got 4x cubed plus 3x plus 2 is equal to 2x plus 1 times 2x squared minus x plus 2. So this will be greater than 0 when 2x plus 1 is greater than 0, because we've shown that this bit here is always positive. So since 2x squared minus x plus 2 is greater than 0 for all x, so that's shorthand for that. Of course, you don't have to use this, right? But it's common shorthand in university maths. You might as well see it now. And this is pretty easy to solve, right? 2x plus 1 greater than 0 gives me 2x greater than -1. X is greater than -1/2. So that's our final answer for that one. Let's just look at the mark breakdown there and see how it went. Well, this part was worth 3 marks. Now, you don't have to use the discriminant for that last bit. There's another way that you can do it, and it's all of your favourite way, and that is with completing the square. So if I want to try looking at this bit here to see when this is positive, I could complete the square on 2x squared minus x plus 2. And I'm going to do that at the end here, just as a brush up. So 2x squared minus, where are we, minus x plus 2 is not that nice at completing the square one. We have to take out a factor here of 2, so we get x squared minus a half x plus 2. That will give me 2 into x minus a quarter squared. All right, so I'm halving this term as usual, plus 2 minus 1/16 times 2, so minus 1/8. And here we get plus 15 over 8. So it's messier than doing the discriminant, but I think in some ways it's more intuitive to see that what we've got here is this is always positive. And because this ends up being a plus 15 over 8, the whole thing is always positive. So there are two go-to methods for showing that something's positive, and that's to look at the discriminant if you've got a normal way up the quadratic, and also to do completing the square. All right, thanks for watching. I'll do some of the other ones later on.